Let's do an example with Venn diagrams. Number 1, a recent survey of seniors found that of the 547 students, 500 are taking a math or science class, 400 are taking a math class, and 350 are taking a science class. We're going to draw a Venn diagram representing this information, and then we'll also find out how many students are taking both math and science. So as I read this problem, what I see here is that we have 547 total students. That's going to represent our universal set. So I'll just go ahead and say that U is equal to 547. It also says that 500 students are taking math, and one big word that I see there is or science. So because of that, I'm going to go ahead and say with my notation, the number of students taking math or science, okay, so that there's our union symbol, is equal to 500. We also know 400 are taking math, so the number of students taking math, just math, is 400. And also 350 are taking science, so the number of students taking science is 350. So drawing a Venn diagram, what I want to show is my universal set. My universal set can just be a rectangle, right? And we know that there are 547 students altogether. Now we know that we're going to have two circles because we're dealing with two categories. We have math, we also have science. So we have an M circle and also an S circle. Now, based on the information given here, let's see here. If we know that the number of students taking math or science, remember what that looks like. Math or science will involve both circles, so we kind of get that peanut shape out of it. Well, we know that all together then, that's going to give us, I'll just kind of write it here, 500 students. Which means if the entire rectangle is 547 and this piece is 500, then what we can do is kind of like punch out that piece, take it out, and you'll be left with whatever is like out here, right? So we can just basically do like a little bit of simple math and say what we want to do is do the 547, subtract the 500 that is math or science, and we'll get the remainder of that. So outside of our circle, we see that there are actually 47 students who are not taking math or science. Okay, so that can be some helpful information later on. What we also want to do is just kind of break up our circle of math and science. You know, we know that there's 500 students making the combination of the two circles, but how do we find out just the inner parts of those circles, right? So what we can do is involve our inclusion-exclusion formula. We know that the number of students taking math or science is given by the number of students taking math plus the number of students taking science minus the number of students taking math and science. Just kind of using our formula from up above, our inclusion-exclusion principle. I'm going to fill in some missing pieces of information. We know that the number of students taking math or science is 500, and the 500 is made up of a couple of different things. We know that the number of students taking math is 400, and the number of students taking science is 350. And so what's left over is the number of students taking math and science. So going ahead to solve this, I'm just going to bring that over. I'll bring the 500 over as well. So we'll see the number of students taking math and science is going to equal 400 plus 350, and then we'll have to subtract 500 from there. So what'll that give us? That'll give us 750 minus 500. So we'll see that we have 250 students that are taking math and science. That's actually going to help us. Let's actually fill in some of the parts of the Venn diagram that we now know. So this piece that is math and science, we actually just found that right here, right? This is the number of students taking math and science. Inside that, we've got 250 students, okay? Now, keep in mind, if that's 250 students, well, if the number of students taking math altogether is 400, and this is 250, then what we can do is actually find this amount, the number of students who are strictly taking math but not science. So if we actually do 400 minus 250, we can see that that amount is actually going to give us 150 there. Okay? And then we can do the same thing with the science people. So if we take into consideration, here we have just the science people, and we want to take out that 250. This is 250. We know number of students taking science is 350 overall. So, this little piece here is going to be 350 minus 250, and that'll give us 100 people. Okay, so in here we have 100 people. In the other crescent, we have 150 people. And you can just check your work. You can add them up, right? If you have 150 people, 150, plus the middle section, which is 250, plus the other section, which is 100, that's going to give us a total of 300, 400, 500 people. And that corresponds with what we saw earlier. The number of students taking math or science is 500 people. Okay? But now that we have all the missing pieces of our Venn diagram, we can now address some of the questions that you see down below. Now notice a lot of these questions, these 4 scenarios here, they all look very similar, but it's very important that you phrase it in such a way that it actually describes what you're trying to find here. For example, in C, this is asking for the number of students, and I'll just abbreviate students with SS, the number of students who are, and then notice what you see here. This bar here means not taking. So what we're saying is the number of students not taking, and notice how that bar is above both math or science. The number of students that are not math or science. Let me rephrase that. The number of students not taking math or science. And then what I want to do is, you notice what I did was I kind of gave a break there. Not math or science. So really what you want to look for in this Venn diagram is if we say not math or science. Well, math or science are this piece here. So when we say not math or science, then we're saying everything but that, which is all of this. This is what we want to find. The purple part is what we want to find. And what's that purple part? Well, if we look up above, we labeled that as 47. So our result is just going to be 47 here. The number of students not taking math or science is 47. Let's try another one. Let's do letter D. Number of students, again, and I want to phrase this in such a way that, you'll notice that the way I say it verbally is going to be different from the way you just kind of read it out. I just want you to be able to see, what is the emphasis? What are you really looking for here? We're trying to find the number of students, and then what are we trying to find? Who are not taking math, not taking math, and, because of the intersection, and taking science. And again, I want to give that verbal emphasis on what we're trying to find. The number of students not taking math and taking science. There's 2 things here. The number of students not taking math and taking science. So, as we look at our Venn diagram again, what are we trying to find? The number of students not taking math. That's one thing. Not taking math. What is that? The number of students not taking math, I'll do this in different colors. The number of students not taking math would be everything but the math circle. Notice what I'm shading here. The number of students not taking math is all this. And then, and taking science. Let's do taking science in a different color now. What's taking science look like? Taking science would be all this. Okay? Taking science would just be the entire science circle. Now, because we use the word and, we're looking for the overlap of what we did in green and what we did in blue. Because of the word and, we're looking for the overlap of what was shaded in green and shaded in blue. What was that shape? Where green and blue meet, you'll notice you actually form the crescent shape. This is the area that you want. So the number of students not taking math and taking science is the crescent shape, which is, as we look up above, oh, we had it right there, which was 100 people. So this is going to be 100 people, just like that. Okay, so I'll leave the other two for you to give it a try in your groups. Let's take a look at example 2 now. Sketch the Venn diagram. All three sets intersect each other. Notice how we have an A, B, and a C here. So when we're looking at these examples, we actually need 3 circles. We need an A, we need a B, and we need a C. Okay, so very similar to how we did the previous problem, we need to think about what it means to see each of these parts. In this case, here, we're saying what we want is A and B. Okay, that's one part. And what we want to find is the intersection, or and, the intersection of, and then I'll do this in a different color, of, and then this part is saying C or B. Okay, so we want to find those two things. So let's first go ahead and find A and B, okay, because we need to break this up into parts. So if we find, and let me do this in a different color again, so purple is going to be A and B. Since we want to find A and B, where does A and B occur? Well, that occurs where A and B both share the same properties, which is right there. Okay, that's A and B. And then in green, now we need C or B. Now, because we have the word or, we can have just C, or we can also have B. So B would also be this part. Okay, just like that. Now, what are we looking for? Well, keep in mind, we need to join the two together with and, which is the intersection. Where is the intersection? Basically, what this is asking is, where is the intersection between purple and green? Where do purple and green both get shaded? And hopefully what you see is this is the area where purple and green both get shaded. So we just kind of show this representation there, just that area there. Okay? So again, I leave it to you and your groups to finish off the rest of this.